Hello, this is Dr. Nak, and we are going to go over section 7.6, graphs of sine and cosine functions. So I went ahead and drew some pictures out already. So let's first go with the sine graph. Now, sine and cosine graphs both look like wave graphs. But anyways, if you look at the positive values for x on the positive side of the x-axis, sine graph starts from 0 and then 1. Remember, the range for the sine and cosine is from -1 to 1. So you're going to go 0, high, 0, low, 0. In that order. Okay? And I've already listed some of the values for x and corresponding y value. So when x is 0, y is 0. And notice that when x is pi over 6, which is right here is pi over 6, it's going to assume 1/2. At pi over 2, it's going to assume 1, and so forth. Okay, now let's look at the cosine graph. It looks very similar, but the difference is that if I look at the positive side of the x-axis, it's going to, instead of starting from 0, it's going to start from 1. So you're going to go high, 0, low, 0, and high. All right, so that's the cosine graph, and you are going to have to memorize these two. Okay, so the next one is the properties of y equals sine of x. We've studied this before in previous sections, but let's just do some little summary. The domain is set of all real numbers. Range goes from -1 to 1. And sine is an odd function. Now, if the function is odd, when you graph it out, the graph is going to be symmetric with respect to the origin. Sine of x is periodic with period 2 pi. And x-intercepts x-intercept is where the graph touches or crosses the x-axis, are -2 pi, -pi, 0 pi, 2 pi, 3 pi, and so forth. And the y-intercept is going to be 0. Y-intercept is where the graph is going to touch or cross the y-axis. And the maximum value for the y is going to be 1, and which occurs at a -3 pi over 2, pi over 2, 5 pi over 2, and so forth. And the minimum value is going to be y equals to -1, and that occurs at a -pi over 2, 3 pi over 2, and so forth. Okay, so now first what we're going to do is, before we get to the cosine graph, we're going to have to learn how to graph y equals a sine of that's omega x, but you can call it wx using the transformations. Okay, so first let's look at the left-hand side of the graph, y equals the sine of x. So the range was from -1 to 1. And now let's look at the right-hand side of the graph. Do you see that the function now is y equals 3 times sine of x? So what's going to happen is that 3 is going to be called the amplitude. So basically, if you multiply the sine of x by 3, you're going to stretch vertically by a factor of 3. So instead of from -1 to 1, you're going to have -3 to 3. And y equals 3 sine of x. Of course, the domain is all real numbers. Now, only difference is the range. Range is going to go from -3 to 3. Okay, so let's do an example. Graph y equals -3 sine of 2x by using transformation. Okay, so first start out, since you're going to have to graph something of the sine function. Step number 1, let's go with y equals sine of x, and then we'll just transform that graph. Okay, so the original graph is usually called the mother graph. So let me just write that out. So this is the mother graph. Or you can call it a father graph, whatever you want. All right, so if I graph that out, remember the graph of sine, -1 to 1. So here it's gonna have what? 0, high, 0, low, 0. So let me just connect these dots. And you know my issue about graphing, right? Or drawing pictures. I am not the best. So let me just go here and here. That's not bad. That's actually kind of good looking graph right there. Okay, so now so that's the y equals the sine of x. So now let's look at y equals 3 sine of x. So 3 is called the amplitude. So let me just go with circle 2. Y equals 3 sine of x. So instead of the range being from -1 to 1, what's going to happen is that your range is going to go from -3 to 3. I know this is completely drawn off the scale. I apologize. So what's going to happen is 0 high, 0 low, 0. Oh my goodness. All right, and then I'm going to have this same situation on this side. Just like that. Okay, so the amplitude changed to 3. So basically, vertical stretch by 3 units. Oh, one more thing. Notice that our period is 2 pi for y equals the sine of x and y equals to 3 sine of x. Because look, from here, let me just use that beautiful feature that I have. From here to here is 2 pi. Oops. Oh my goodness. Sorry. Okay. All right, so period 2 pi means that starting from 2 pi, your cycle restarts again. So starting from 2 pi all the way up to 4 pi, you're going to have the same exact graph as what you drawn from 0 to 2 pi. Okay, so for the third step, let's draw out y equals -3 sine of x. Now, if you do that, 0 is going to stay as 0. Now, 3 is going to become -3. And -3, wherever the graph touches -3, it's going to go to +3. So basically what's going to happen is you're going to have to reflect the above graph by the x-axis. Okay, so let me try to do that. Oh man, I hate drawing pictures. All right, so let me see. First, I need to write 3 and -3. Okay, so looks like I'm gonna have, starting from here, this is gonna go up to 3, and then 0, and at pi over 2, it's gonna assume -3, and then 0, 3, and then back to 0. So it's gonna look something like this. Oh my gosh. All right, now what is the period of this? The period is still 2 pi. So let me just do that. Okay, so now let's go to the fourth step. Fourth step is going to be y equals, what we're looking for, y equals -3 sine of 2x. Okay, so that means what? You're replacing the argument with x in it by 2x. So x is going to change to 2x. that means what's going to happen is we're going to get a horizontal compression by a factor of 1/2. Now I'm going to show you how to graph something like this in my way right after this. So it might be a little bit easier to do it this way, but I'm trying to follow what the textbook does for now. And then I'll just show you how I would do it, maybe on the next example or towards the end. But anyway, so what's gonna happen is this. You're gonna have to compress. We're gonna do the horizontal compression by a factor of 1/2. So here you're gonna have pi over 4, negative pi over 4. And then this is what? Negative 3 pi over 4. And here is 3 pi over 4. And just like that. All right, so let me just draw this out. So instead of at negative pi on the above graph, that point is going to go to negative pi over 2. So you're going to have to start from here. And, oops, I forgot to write the 3 and a negative 3. Then what's going to happen is at negative pi over 4, you're going to go to the top, which is 3. And then you're back to 0 at 0. And then at a pi over 4, you're going to go towards the negative 3. And then at a pi over 2, you're going to come back to 0. And then 3 pi over 4, you're going to go up to 3. And at pi, you're going to go back down to 0. So basically one cycle got smooshed down almost, scrunched up by a factor of 1/2. So let me just try to draw this out. Oh my gosh, this is a lot harder than you think. All right, so it's gonna keep going like this, but this will be just the pretty much the same cycle as we've drawn for the all other 3 graphs. Now let's talk about the period of this. Okay, so notice that period is no longer 2 pi because this graph's going to repeat itself from pi on. I don't know if you can see that. So here, your period is going to become pi. Okay, and then furthermore, let me just write down what's going to happen for circle 3 and circle 4. So here, reflect about the x-axis. And for this one, horizontal compression by a factor of 1/2. And so the very bottom one, circle 4, is the graph that what we're looking for. Okay, so let's just try to do this how I would do it, but you don't have to do it this way, of course. There's always more than one way to do math. But let's try to graph this out, the same graph that we just graphed it out by doing step by step by step. But first, let's talk about the amplitude. Okay, now the amplitude is nothing but an absolute value of -3. In this case, it's 3. So this number, absolute value of the coefficient on the sine function, is going to become the amplitude. Absolute value of -3 is 3. So instead of the graph going from -1 to 1, you're going to go from -3 to 3, and that's all. All right, now let's talk about the period. Okay, now what was the period for the sine? It was 2 pi, wasn't it? So here, I'm just going to go, period is 0 to 2 pi. Now, what to put in between would be the argument of the sine. Argument of the sine is 2x, so I'm just going to squeeze in 2x, and then just solve for x. How do I solve for x? Is multiplying by 1/2 or dividing by 2. So then here what we're going to get is what? Now x is going to be between 0 to pi. So instead of being period 2 pi, we're going to have a period of pi at the very end. period pi means what? So your cycle is going to start at a multiples of pi. Okay, so I usually draw the mother graph regardless, just so that I know what the sine graph looks like. So let me just go with, keep in mind y equals the sine of x. So that's my mother graph. Is going to look something like this. Oh my goodness. So this is pi, 2 pi, and so forth. So this is pi over 2, negative pi over 2, negative pi, 3 pi over 2. Okay, so keep that graph in mind. So what's going to happen is this now. So let's first graph out y equals positive 3 sine of 2x. Okay, so if I do that, using the information that we obtained from above, which is the amplitude and the period. Okay, so instead of starting from 0 to 2 pi, you're going to go from 0 to pi instead. So this point is just going to be pi. And then, so that means what? This point will be, halfway will be pi over 2. Half of that will be pi over 4. And then this point right here, it will be 3 pi over 4. So here you're going to have negative pi over 4. And instead of a negative pi, you're just going to have negative pi over 2. And we know that the amplitude is 3, right? So we're going to go negative 3, 2, 3. And all you have to do is draw a sine graph, just like the mother graph that you drew. So you got to go 0, high, 0, low, 0. And so this will be just one cycle. Instead of 2 pi, your one cycle is going to be pi, and that's all. And dot these points. Oh my gosh. All right, but anyways, that will be the graph of y equals 3 sine 2x. And then lastly, multiply by the negative. So if you're going to multiply by a negative 1, all you got to do is flip that graph over. Okay, so step 3, y equals negative 3 sine of 2x. Okay, so let's do this. So it's going to be 0 instead of positive 3. It's going to go to negative 3, 0, and then like this. And voila, there we go. All right, so that's the graph of y equals negative 3 sine of 2x. You don't have to do it this way if you don't want to. You could just do it step by step if you like. But I just wanted to show you how I would do it. Okay, so now let's talk about the properties of y equals cosine of x. All right, so the domain is all real numbers. Range is from negative 1 to 1, just like the sine function. And y equals the cosine of x is an even function. That means graph is symmetric with respect to the y-axis. And y equals to cosine of x is periodic with period 2 pi. And x-intercepts are negative 3 pi over 2, negative pi over 2, and so forth. Y-intercept is y equals to 1. And maximum value is y equals to 1 and occurs at negative 2 pi, 0, 2 pi, 4 pi, 6 pi. Minimum value is y equals to negative 1, and that occurs at negative pi, pi, 3 pi, 5 pi, and so forth. Okay, so now let's look at the sinusoidal graphs. I have such a hard time saying that word, sinusoidal. All right, but anyways, shift y equals cosine of x to the right, pi over 2 units. Then the new function is going to become y equals cosine of x minus pi over 2. And I already drew the graph of y equals to cosine of x. And then y equals to cosine of x minus pi over 2. Alright, so notice that when I shift the graph to the right pi over 2 units, do you see that? What I meant to say is if I shift the cosine graph to the right pi over 2 units, do you see that that's exactly the same thing as the sine graph? So therefore, this property is true. So let me just write it right here. This property right here, sine of x is nothing but cosine of x minus pi over 2. And we say that the function of the form y equals a sine of wx or y equals a cosine of wx as sinusoidal functions. W or omega, whichever you want to say it is okay. Let's go over the theorem. If omega is greater than 0, the amplitude and the period of y equals a sine or cosine of omega x are given by amplitude is the absolute value of a, and period is denoted by t, which is 2 pi over omega. Now the steps for graphing y equals a sine or cosine of omega x. So this is straight from the textbook, but anyway, step 1, find the amplitude and the period. Step 2, divide the interval 0 to 2 pi over omega into 4 subintervals of equal length. Step 3, use the endpoints of subintervals to plot key points on the graph. Step 4, plot 5 key points and draw a sinusoidal graph of one cycle. Let's take a look at example 2. Graph y equals 9 over 5 cosine of negative 3 pi over 2x by the method of key points, which means that follow the previous steps. Step 1 through, how many steps do we have? Steps 1 through steps 4? Alright, so I'm going to do this strictly the way how your textbook does it, following step 1 through step 4. Okay, so before I do this, remember cosine is an even function, wasn't it? So let me just rewrite this. So this graph is same thing as 9 over 5 cosine of 3 pi over 2x. I just don't like to deal with the negative argument. Okay, so let me just write down from here to here because cosine of x is even. It's an even function. Okay, so let's go with step 1. Step 1 is to find the amplitude and a period. So I'm just going to leave it as amp. Amplitude is absolute value of a, so this is your a, which is absolute value of 9 over 5, which is 9 over 5. And the period is, the formula is 2 pi over omega. So maybe I should write down this. So this is of the form y equals a cosine of omega x. Okay, so in this case, our omega is 3 pi over 2. So this is going to be 2 pi all over 3 pi over 2. So which is what, 4/3? Okay, now let's go with step 2. Okay, so what they want you to do is divide 0 to, I'll just write down all the instructions here, 2 pi over omega, which is 0 to 4/3, into 4 subintervals of equal length. Okay, so let's see what the increment's gonna be. So to find the increments, you could just go what? Whole intervals 4/3, and you're gonna divide that by 4. So that's what, 4/3, multiplying here by 1/4. So it looks like each increment is going to be 1/3. Okay, so basically what that means is this. You're gonna chop up this interval from 0 to 4 over 3 into 4 equal subintervals. So this is going to be 1/3. and this is 2/3 and 3/3, which is 1 and 4/3. Now step 3, I'll write the instructions. Use the endpoints which are 0, 1/3, 2/3, 1 and 4/3 to get key points. Okay, so let me just make a chart. So here's x, and this is y equals 9/5 cosine of 3 pi over 2 times the x. And then let's just jot that out as an ordered pair, x comma y. So I'm going to draw this graph. I don't know how much room I'm going to be needing, but okay. So let's go with when x is 0, you're going to have y equals 9/5 cosine of 0. Cosine of 0 is 1, so 9/5 times 1, which is 9/5. So when x is 0, y is 9/5. Okay, now let's go with when x is 1/3, y is 9/5 cosine, that's a 5, sorry, cosine of, what is that, pi over 2? So which is going to be 9/5 cosine of pi over 2 is 0, so you're going to have a 0. So you're going to have to plot 1/3 comma 0. And when it's x is 2/3, y is 9/5 cosine of pi. Cosine of pi is -1, -9/5. So this is 2/3 and then -9/5. Okay, so what's next? 1. So y equals 9/5 cosine of 3 pi over 2, which is 9/5. Cosine of 3 pi over 2 is 0, which is 0. So what do we got? 1 comma 0 is where we need to plot. We got this. One more. 4/3. Y equals 9/5 cosine of 2 pi. Alright, so this is what? 9/5 cosine of 2 pi is 1. Okay, so here is 4/3 comma 9/5. Alright, so now let's graph this out. So step 4, graph. I don't know why I'm writing this so big, but that's okay. Alright, so let's go with okay, so 0, and then this is going to be 1/3, 2/3, and 1, and then 4/3. And that means this is -1/3 and -2/3. If you can hear the background, that is just Kasha drinking water. Alright, now the amplitude is what? 9/5. So up to here, you're going to go 9/5. Geez, Kasha, are you thirsty or what? And then here you're going to have -9/5. Okay, so let's plot some points here. So when x is 0, you're going to have to plot 9/5. So let me change the color. Always, please always label your points. So this is 0, 9/5. And when x is 1/3, here you're going to have 1/3 comma 0 and 2/3. It's going to be -9/5. And then back to 1 comma 0. And then back to 9/5. So this was what? 1 comma 0. And this point is 4/3 and 9/5. Okay, so let me just go on this side as well. So my graph, I should say our graph is gonna look like, that's not bad. That's actually, I'm doing a pretty darn good job right now. I think that might be the most beautiful sinusoidal graph that I've drawn. All right, so anyway, so this is the answer, which is that graph. Okay, I just also wanted to show you a different way to do it. This is the way I do it, but you don't have to, again, you don't have to follow this. So to graph the same thing, same graph as the previous example, which is example 2, I'm going to start out with, well, first step is the same because I know that the cosine is an even function. So this is going to happen. Okay, so again, our amplitude is absolute value of 9/5, which is just going to be 9/5, and the period. Now, what is the period for cosine? Period of cosine is 2 pi, wasn't it? So I'm going to go 0 less than or equal to something less than or equal to 2 pi. Now remember what goes in there? What goes in there is the argument for the cosine. So here you're going to have, oh sorry, I'm dealing with the positive argument now. So here what we're going to get is what? 3 pi over 2 and then x. So solving for x, how do I solve that? Is what? Multiply this whole thing by 2 over 3 pi to solve for x. So if I do that, then here you're going to have 0 less than or equal to x less than or equal to, if I multiply, then you're going to have 4 pi over 3 pi. Pi is going to cancel, so you're just left with 4 over 3. Okay, so instead of the cosine graph going from 0 to 2 pi, you know that the one cycle is going to end at from 0 to 4/3. All right, so let me just box that. So again, I'm going to draw the mother graph. Just so that I don't forget that we're dealing with the cosine of function. All right, so the cosine starts from -1 to 1. It's going to go high, 0, low, 0, high. Here we go. And let's just go. All I need is one cycle, but let's just get fancy and just go over here as well. All right, so that's the mother graph, y equals cosine of x. So now to graph this out, graph what we want to graph out. So first, I'm going to try to draw this out like this. All right, so instead of from 0 to 2 pi, the 2 pi mark is going to become 4/3. Okay, and then you're going to chop this up into 4 equal length. So that portion, you do the same business as what we did before. So you go 4/3 dividing by 4. So this was what? 1/3. So you know that the increment's going to be 1/3. So you're going to have 1/3 and then 2/3. 3/3 is 1 and 4/3. Okay, and then this is going to be -1/3, -2/3. All right, and then what? Amplitude is just 9/5. And all you have to do is copy the mother graph. Oh my goodness. Boy. Okay, so I'm done. So this is the graph of, I mean, you can plot the points, right? So this is what? 0, 9/5. And this is what? 1/3, and y is 0. 2/3, -9/5. And this is 1, 0. And this is 4/3 and 9/5. Just like how we got it before. So therefore, this is done. I'm done with it. Y equals 9/5. Cosine of -3 pi over 2x is this graph right here. Okay, example 3, find an equation of the graph. So instead of drawing the graph, we're given the graph and our job is to find that equation. All right, so let's start out with the amplitude. Okay, so the amplitude was absolute value of A. Okay, so the amplitude, it looks like it's the lowest point will be y equals to -3/2, and highest point of that graph is -1/2. So let's find out what the middle point is right there. So isn't this what, 3/2 minus 1/2, and whole thing dividing by 2, that's what, 1/2. So it looks like our amplitude is going to be 1/2. Do you see why I subtracted 3/2 minus 1/2 and divided by 2? Because look, our amplitude is going to be from this distance right here. So this is going to be our amplitude. So first, what I'm doing is computing the distance between -3/2 to 1/2 and dividing that by 2. So the amplitude is going to be 1/2. Okay, now next, let's go with the period. Okay, so period was 2 pi over omega. So our job is to find that omega and the period. So let's look at, looks like one cycle is gonna end at 4 pi over 3. So, okay, so from, sorry, I should have drawn that in red. So from here to here was the period, which is what, 4 pi over 3? Okay, so it looks like period is 4 pi over 3, so 2 pi over omega better equal to 4 pi over 3. Now solving for omega, because omega is going to be the argument of the function. So if I cross multiply, what do we get? 6 pi equals 4 pi omega. Dividing by 4 pi, so it looks like omega is going to be 3/2. So that means what? So therefore, we now have, what do we got? Either y equals 1/2 sine of omega x, which will be 3/2x, or y equals 1/2 cosine of 3/2x. It's either one of those. It's going to look like something like that. So we now have either. I should have wrote down either. All right. So you know what? Let's just graph y equals 1/2 sine and cosine of 3/2x is going to look like on the graph above, just to play with it. Let me change the color real quick. So let me see. Let's go with 1/2 sine of 3/2x first. So from here to here, it's going to be 1/2. Amplitude is 1/2, right? And since it's a sine graph, let's do this one in maybe green color or something like that. It's going to go 0, high, 0, low, 0. Okay, so I'm just going to go like this. Okay, so this, the one that I just drew right here is y equals 1/2 sine of 3/2x. Okay, I was going to do 1/2 cosine of 3/2x, but I don't think I need to, because look, the green graph and the graph that, what we want, do you see that to get what we want, you're going to have to reflect y equals 1/2 sine of 3/2x. you have to flip it, meaning reflect this about the x-axis. Okay, so if I do that, let me just try to draw that graph out. Oh my gosh, I hate drawing. So this point's gonna be positive 1/2, and it's gonna go to 0. Wait, is that right? Okay, and then this, oh my gosh, why do I have to draw the pictures? Okay, this is gonna go here, and this one, and dot here, and dot there. Did I do this right? Ugh, this is so hard. Okay, all right, not so bad. So the graph that I just drew is y equals, so it's a reflection about the x-axis. So what we need to do is just multiply the function by -1. So this is the graph of y equals -1/2 sine of 3/2x. I hope you can see this color. Sorry about that. Okay, so almost done. So now just look at the yellow graph that I just drew and the graph that what we want. So basically, we need to shift that yellow graph down by how many units? Looks like I need to shift it down by what? 1 unit down? Then, so if I shift the yellow graph 1 unit down, do you see that we're gonna get the graph that we want? All right, so don't worry, I'm gonna write everything out. So, okay, so note that the equation we want is y equals 1/2 sine of 3/2x reflected about the x-axis. Then shift the graph shift the entire graph down by 1 unit. So if I reflect, so therefore, if I reflect about the x-axis, our graph now becomes y equals what? -1/2 sine of 3/2x. Okay, and then if I shift 1 unit down, that means what? We're going to have y equals -1/2 sine of 3/2x. You're going to shift it down by 1 unit, so you're going to have to go -1. So it looks like our given graph, equation of the given graph is y equals -1/2 sine of 3/2x and then -1. So on the next page, what I did was in case you forgot, what you need to do for the vertical shift, horizontal shift, and whatnot, I just copy and pasted these properties from college algebra textbook. So feel free to go over that if you like. All right, so that is it for this lecture, and good job.